Hello, thanks for the opportunity to present here. Our hybrid, not cloud, but hybrid architecture for large-scale analysis of genomes, of cancer genomes, and machine learning that we used for stratification of cancer patients, because this is what we do in M&M Diagnostics. We're a group of engineers, molecular biologists, bioinformaticians, data scientists that develop diagnostic tests for personalized cancer therapy. So we do profiling of the cancer using whole genome sequencing, and then apply machine learning methods to match the tumor with the treatment that will hopefully kill it. So this is how it works. When the tumor is dissected from the patient, we extract DNA from it, we put it on a DNA sequencer, and read out 200 billion letters, so the DNA sequences that we find. We look at the differences that happened in the tumor, the changes, and then we make so-called tumor profiles that are later used in machine learning to classify the patients for the treatment. So the data processing that happens between the raw data that flows off the sequencer and then the changes that are turned into profiles. This is done by a sequence of bioinformatics tools that we chain together in so-called pipelines. You can imagine these pipelines as bash scripts where individual commands are executed, but there are much more sophisticated ways of building pipelines. And we use Nextflow, which is a workflow language and engine that automates a lot of common tasks. So it does parallelization, it containerizes individual tools, the boxes that you can see in the plots here. It abstracts the definition of the pipeline being directed at cyclic graph most often from the execute environment. So we can take the same pipeline and put it into a different execution infrastructure. So we started building our first local and cloud infrastructure around these pipelines. So the first one processes raw genomic data from the tumor, generating a set of files for each sample. These files are then ingested into the second pipeline that makes the tumor profiles, and that next are loaded into a Mongo database where they can be fetched from for the machine learning, for building the models. You can see sizes of the data we work with. This is per sample sizes on the top. We process hundreds and thousands of genomes in our work. The run times of the individual steps are on the bottom, depends on the compute environment, but it's hours to days for a single sample. This is our research and development pipeline. It's not a production system for external customers. It's to build products internally. And we use external repositories of data, of genome data to build our models. One of the problems we noted here is that the failure rate of the process was quite high because of we didn't have the control over the data that flows in. So we ended up building separate pipelines, dedicated pipelines for each of the repositories that we use. Also Nextflow pipelines that homogenize data, that QC the data, and we only introduce genomes that are good enough for the downstream processing. This complicated the architecture a bit, so we have a lot of pipelines to automate. So we started using Airflow, Apache Airflow, to build execution environments automatically for the individual steps, to run the Nextflow pipelines, to rerun them if necessary, to move the data and load it to the database in the very end. So this is a work in progress. It's been working very nice, but it's not complete yet. One other improvement that we made is we noticed that some of the machine learning methods would benefit from using the raw results. So not the features that we designed here in the machine learning terms, but the raw results that are outputted by the genome processing pipeline. So we added a data warehouse where we load the flat files to. They are stored in a structured format in Parquet files and Delta Lake allows us to query them using Spark, and Glow provides a convenience layer for typical bioinformatics formats, so we can ingest and extract data in known formats. So this has removed the troubles we had with accessing individual files, and we have one additional entry point for accessing the data for machine learning, for building the models. So in the last part, I would like to name a few technologies that we use. So we primarily focus on the local, or work on the local stack now. Where for the heavy computing, we use Poznań Supercomputing Center with Lustre file system and Singularity containers. And then we move the results for the post-processing to an on-prem service where we use Docker, and we have the MongoDB and Delta Lake set up, and all the machine learning happens there. But at the same time, we built infrastructure on Amazon Web Services with S3 providing the storage layer, and we can run the computations using Nextflow on EC2 instances on demand and spot through AWS Batch. And then the part with the Delta Lake and Spark server is created using CloudFormation and Amazon AKS Kubernetes cluster. So we're planning to move also the machine learning to the cloud, but this is something that's not entirely ready yet. So this is it for me. I'll be happy to take comments and questions.